This video is going to focus on point-slope form, which is another variation of the slope-intercept formula in a way that we can use just the point, any point that's on a line, and the slope of that line to create an equation that describes all points on that line. Now the point-slope formula is right here, and we see we have y minus y1 equals m times x minus x1. A couple things we need to remember. M is your slope. x1 and y1, that is the point on the line you are trying to create. And what the point-slope form does for us is it says, as long as we know one point at all, and the slope, we can create that line. If we remember from our slope-intercept video, which I'm going to do over here real quick, y equals mx plus b, to use slope-intercept form, we need to know the slope, which is m, but we also need to know the y-intercept, which is b. And if we don't know the y-intercept, we have to figure that out. With point-slope form, all we need to know is the slope, and we need to know some point on the line. And then it's just a matter of taking all of our variables, the m, the y1, and the x1, and substituting them into this formula to create the point-slope form. Let's take a look at an example. Let's say we're asked to use the point-slope form, which I've rewritten here, to create the equation of a line that has a slope of 2/3, and the line contains the point -4, 6. Well, what do we know? We know our slope, which is m. Slope is always m. And we have a point, and the point is made up of an x value and a y value. So this would be x1, this would be y1. Now we take our specific values that we're given and we substitute them in to our equation. So instead of having y minus y1, I would have y minus 6, because 6 over here, that is our y coordinate, equals, instead of m, I would have 2/3, because 2/3 is our slope. We see it right over here. And then we are multiplying that times x minus, and now we are subtracting a -4. And that is what this equation would look like. There is one other thing we could do, though. I never like writing minus a negative. So what we could do instead is have it be x plus 4. Since we are subtracting a negative, those would become a positive. So we could write this in place of that, and it would be the exact same thing. So, the joys of point-slope form: all we need is the slope and a point. We don't need to know any y-intercept, and then we can graph it. So let's see an example of graphing with this information and using the point-slope form. Alright, this time we are going to graph a line that has a slope of 1/3, and it contains the point -6, 2. Now if you remember from our slope-intercept video, we always started with the y-intercept, but I don't know the y-intercept this time, so instead I'm going to start with the point that I have. I'm going to go 6 to the left on our x-axis, and I'm going to go up 2 on our y-axis. So we'll have 1, 2, 3, 4, 5, 6, and then up 2, and that is where our point is going to begin. So let me put that in. Now from this point, we are going to follow the directions of our slope. The slope is positive, so that means we are going up 1 and to the right 3. So from our starting point, we'll go up 1 and over 3, right here. And then we'll do that again. Up 1 over 3. And that'll get us to right there on the y-axis. So we actually find our y-intercept. We didn't need to, but we did. And then we would continue this and eventually connect the dots. And we're going to have a line that looks something like this. Now, if I put this information into our point-slope formula, I'll have the equation for this line. So, remember, we have y minus y1 equals m times x minus x1. y1 is 2. x1 is negative 6. And m is 1/3. So let's just plug in what we know. Y minus 2 equals m, which is 1/3, times x plus, I'm going to do a plus instead of the minusing a negative, x plus 6. And there we have our equation. So, point-slope form is pretty nice to use. We can get our equation for our line and graph it all from there. But it has one more nice feature where, let's say we have this, and we really wanted to actually have slope-intercept form. We can easily change this into slope-intercept form. So let's try that. Let's take this equation, and we're going to convert it into slope-intercept form. So if we're going to change our point-slope formula into slope-intercept form, the main thing we have to do is solve for y. Notice how y is not alone. Y has a minus 2 with it. So we're going to have to solve for y to get it into slope-intercept formula. And we'll have to do a couple of things, but that's the main thing. We want to have it solved for y. So what can we do to get rid of this minus 2? Also, if you feel confident that you can already change this into slope-intercept form, feel free to pause the video. Give it a try. Come back and check your answer. Well, if I want to get rid of a minus 2, I have to add it back. So I'm going to start by adding 2 to both sides. That's going to give me y equals, I didn't do anything to this part. So this is going to stay exactly as it is. And I can't add the 2 to the 6 yet because this is inside parentheses. This is not. So everything else is going to stay the same. 1/3 times x plus 6. And then we're going to have the plus 2 on the outside of it. We've solved for y, which is what we needed. But hopefully you're noticing this doesn't really look like this yet. There's a couple other things I have to do. I need to get rid of the parentheses, and I need to have like terms combined. So we're going to start by distributing. We are going to distribute the 1/3 inside the parentheses. That's going to give me y equals 1/3 x plus, now 1/3 times 6 is the same thing as 6 divided by 3. And 6 divided by 3 is 2. And then we can't forget our plus 2 at the end. We are almost done. We almost have this in slope-intercept form. But right now it looks like I have 2 y-intercepts. That can't happen. I need to combine like terms. So 2 plus 2 is 4, and the very end gives me y equals 1/3 x plus 4. This is our slope-intercept form equation. And this slope-intercept form gives us the exact same line as this point-slope form. They are just different ways to write the exact same thing. Now there's one last thing we need to talk about in this video, and that is, what if they don't give us a slope? They just give us 2 points. Well, let's see. For this last example, we're being asked to create the equation of a line that passes through these 2 points, -4, 3 and 5, -2. You might think that this isn't possible because everything we've done so far, they gave us 1 point and 1 slope. Here we have 2 points. Well, if we think back, we already know how to find the slope between 2 points. We should remember our equation for slope. M equals y2 minus y1 over x2 minus x1. This equation requires 2 points, which we have, and will give us the slope of the line. So we just have to find that slope first. Now, let's label our pieces. This is my first coordinate, so I'll say x1, y1. This is x2, y2. Take these numbers, and let's put it into our formula here. y2 is -2, y1 is 3. So at the very top, I have -2 minus 3 over x2 is 5, x1 is -4. 5 minus a -4. This is going to give me -5 on top, and 5 minus a -4 is the same thing as addition, so 5 plus 4 is 9. We know our slope now is -5/9. And we can then take this slope and either one of these points will work perfectly well for our point-slope form. We just take the m and decide, do I want to use the first point or do I want to use the second point? It's up to you. If we use the first point, we would have y minus 3 equals -5/9 times x plus 4, and it would be plus 4 because this is a -4 here. Or I could get, if I were to use the second coordinate I'm given, I would have y plus 2 because of the -2 here. Subtracting a negative gives us a positive. So y plus 2 equals -5/9 times x minus 5. And believe it or not, these two are the exact same line equation, just with different numbers, because we're using a different point. If we were to solve these to put them into slope-intercept form, they would turn out to be exactly the same. But we don't have time to do that right now. If you want to test that out on your own, though, be my guest. This line and this line, if you change them into slope-intercept form, will give you the exact same equation. And that's it for point-slope form. I hope you found this video useful, and good luck.